Toshiba Electronic Devices and Storage Corporation. E-learning. Basic knowledge of discrete semiconductor device. Chapter 2. Diodes. This video explains the types of diodes and their characteristics. Types of diodes. Diodes are two-terminal semiconductor devices with a p-n junction or an alternative junction. Table 2-1 shows an example of classification of diodes. They are classified into rectifier diodes, Zener diodes, etc. by structure and usage. Diodes are widely used. Functions of rectifier diodes. A characteristic of diodes is that current flows forward direction, or current does not flow reverse direction, depending on the direction of applied voltage. Utilizing this property, the diode works to rectify the AC voltage. The electrode terminals are called the anode and the cathode, and current flows when the anode electrode is at positive potential. Forward characteristic of rectifier diodes. Forward characteristic of rectifier diode varies according to current level and temperature. At low current region, VF is low at high temperature, and the opposite is true at high current region. In general, the diode should be used with a sufficient temperature margin below the Q point, which is the cross point of the above two conditions. Fast recovery diodes. The structure and function of fast recovery diodes are the same as those of rectifier diodes. Rectifier diodes are used for low-frequency applications below 500 Hz, whereas FRDs are used for high-frequency switching from a few kHz to 100 kHz. Therefore, the reverse recovery time, TRR, of the diode characteristic, which is important for high-speed switching, is short. FRDs are also referred to as SFRDs, HEDs, etc. according to the TRR value. TRR of a general rectifier diode is several microseconds to several tens of microseconds. On the other hand, TRR of an FRD is several tens of nanoseconds to several hundred nanoseconds and is about 1/100th of that of the rectifier diode. It is used in switching power supplies, inverters, DC-DC converters, etc. Voltage regulator diodes, Zener diodes. Voltage regulator diodes utilize the reverse characteristics of a p-n junction. When raising reverse voltage of p-n junction diodes, high current starts flowing at a certain voltage, and constant voltage can be obtained. This phenomenon is called breakdown, and this voltage is called breakdown voltage. Voltage regulator diodes actively use this characteristic. Since this breakdown voltage is also called Zener voltage, voltage regulator diodes are also called Zener diodes. This voltage may be used as a constant voltage power supply or a reference voltage for electronic circuits. TVS diodes. A TVS diode is a kind of Zener diode. It is a diode that is mainly used for static electricity (ESD) countermeasures. It protects integrated circuits and others from high voltage ESD entering from a USB line, etc. TVS diodes absorb abnormal voltage from interfaces, external terminals, etc., prevent malfunction of circuits and protect devices. They are suitable for absorbing and suppressing static electricity or short pulse voltage. Difference between TVS diodes and Zener diodes. 1. As shown in figure 2-6, a TVS diode, ESD protection diode, absorbs very high overvoltage in a short time and works so as not to apply excessive voltage to other semiconductor devices. On the other hand, as shown in figure 2-6b, a Zener diode clamps input voltage to a constant voltage and supplies clamped voltage to other semiconductor devices. Thus, a TVS diode absorbs surge voltage to protect other semiconductor devices, whereas a Zener diode provides constant voltage to other semiconductor devices. Difference between TVS diodes and Zener diodes. 2. TVS diode, see figure 2-7a. TVS diodes are typically used under reverse blocking status. Breakdown occurs only when voltage exceeding a certain voltage is applied to a TVS diode. Zener diode, see fig 2-7b. Zener diodes normally used in the breakdown state. It is assumed that a breakdown current always flows in normal state. Variable capacitance diodes. The variable capacitance diode is a product that makes use of the capacity characteristics of the depletion layer. The depletion layer occurs in the p-n junction of the diode when the voltage is applied in the reverse direction, and the thickness varies in proportion to the reverse voltage. Therefore, as the reverse voltage applied increases, the capacitance decreases. This is the same function as increasing the distance between the two electrodes of the capacitor. Conversely, if the reverse voltage becomes low, the capacitance increases. It is used for tuning circuits, etc. Since the frequency characteristics are changed by this capacitance change, a large capacity change ratio is required as compared with the normal diode. Variable capacitance diodes. The important characteristics of a variable capacitance diode are not the forward voltage VF and switching characteristics as in the case of a general diode, but the capacitance value and its variation, voltage dependence. Schottky barrier diodes, SBDs. A Schottky barrier diode, SBD, is a device in which a semiconductor and a metal such as molybdenum are bonded instead of a p-n junction. In general, SBDs of N-type semiconductor and metal junctions are commercialized. It is suitable for high-speed switching applications, because of small forward voltage and short reverse recovery time. For the SBD there is a trade-off between forward voltage, VF, and reverse current. Depending on the metal used, in general, the breakdown voltage is about 20 to 150 volt and the VF is about 0.4 to 0.7 volt, which is lower than that of the p-n junction diode. SBDs with the new structure with low forward voltage but low reverse current have also been commercialized. Toshiba has achieved low VF and low reverse current characteristics by adopting a trench structure for SBD. Reverse recovery characteristic of Schottky barrier diodes. The reverse recovery time, TRR, of the SBD is determined by the LC resonance circuit based on the junction capacitance and the inductance of the external wiring. Since the junction capacitance is hardly influenced by temperature, TRR is the same from room temperature to high temperature. For p-n junction diodes, TRR becomes longer as the temperature rises. As a result, the switching characteristics of the SBD become more and more advantageous, which makes it suitable for higher frequency switching. Difference depending on metal of Schottky barrier diodes. In the case of the SBD, the semiconductor consists of N-type layers, and so the metal acts as the anode of the diode. Likewise, only electrons are carriers, and the SBD becomes a unipolar element just like a MOSFET. The energy level of silicon differs from metal, energy gap. This energy level differs depending on the metal element. Phi-B is the symbol for this difference. Platinum is a metal with a large energy gap. Vanadium or titanium are metals with small energy gaps. Adopting a metal with a large Phi-B makes leakage current small, but makes forward voltage VF big. For metals with small Phi-B, the opposite tendency are obtained. Characteristics application of various diodes. This list summarizes examples of typical application for each type of diode. The graph shows VF characteristics for each type of diode.